In this video, I'll show you how to find the lateral area, total surface area, and volume of a frustum. This is question 2 in the series. The question reads, a plastic drinking cup has a base diameter of 49.0 millimeters, is 63.0 millimeters wide at the top, and 86.0 millimeters tall. Find the lateral area, total surface area, and volume of the frustum. Before I begin answering this question, I want to discuss what a frustum is. Picture a cone like this, or even a pyramid with its top cut off. What's remaining, this part, is known as a frustum. If you look at the diagram to your left, you'll notice that if we were to extend these two lines, you would end up with an upside down cone. So technically, this cup is a frustum. The first thing that we will solve for is the volume with the help of this formula, where volume is equal to h over 3 times the area of the first base plus the area of the second base plus the square root of the product of area 1 times area 2. The height of this shape is 86, so I'm going to write down 86. And we can start off by finding the area of this base and the area of this base. The base itself is a circle, so we can use area is equal to pi r squared. Area 1 is pi times 63 divided by 2. Remember, this is the diameter to the power of 2, while area 2 is equal to pi times 49 divided by 2 to the power of 2. Using our calculator, pi bracket 63 divided by 2 to the power of 2 is equal to approximately 3117.24 millimeters squared. And next, the area of the second base is pi bracket 49 divided by 2 to the power of 2 is equal to 1885.74. Using this formula, volume is equal to the height of 86 divided by 3. A1 is 3117.24 plus 1885.74 plus the square root of the product of A1 and A2. Using our calculator, 86 divided by 3, that covers this part, times everything in the brackets. 3117.24 plus 1885.74 plus the square root of 3117.24 times 1885.74. Closing these brackets, we end up with a final volume of 212,921. 212,921 decimal 70 millimeters cubed. Now that we found the volume, the next thing that we will find is the lateral area. So I'll highlight what we've just found. Now the lateral area refers to the surface area except for the bases. So in our case, we won't include this, neither will we include this. All we need to find is the area of the sleeve. We will use this formula to do that, where lateral area is equal to S over 2, and S refers to the slant height. How do we find that? The way you find the slant height is to take a two-dimensional view of this three-dimensional shape. And if you look at this object in a 2D perspective, you'll actually create a trapezoid. Let me show you what I mean. Where this represents 63, this represents 49. These two lines are parallel. Obviously, it's a trapezoid, even though it doesn't appear to be so. It's a crude drawing. And the height will be 86. To find the slant height, which will be highlighted in yellow, you'll need to use the Pythagorean theorem. Take a look. This is also a right triangle, as is this one. We know that this is 86, but we don't know this. To find out the length from here to here, what we have to do is take 63, the total length from here to here, subtract it from 49, and that will leave us with two equal parts. So 63 minus 49 is equal to 14. And to find these, they're both equal, we divide by 2, and it gives us 7. So this is 7, and this is 7. 7 plus 49 plus 7 gives us 63. The Pythagorean theorem looks like this. A squared plus b squared is equal to c squared. And I'll draw for you just this part right here. Here we'll have 86. Here we'll have 7. And this, given that it is the hypotenuse, we'll call it c. 86 squared plus 7 squared is equal to c squared. We'll sum these up. 86 to the power of 2 plus 7 to the power of 2. Square root that. We have our hypotenuse of 86.28. 86.28 millimeters. Now we can finally use this formula for the lateral area, where we have LA, which represents lateral area, 86.28 divided by 2 times the sum of the base circumferences. This means, going back to our diagram here, we need to find the circumference of this and the circumference of this. And the formula for circumference, C is equal to pi d. Now, since we'll be continuing this part, put 3 dots. C1 is equal to pi times 63. And C2 is equal to pi times 49. Our formula becomes this part times 63 pi plus 49 pi. Remember, it's the sum of the circumferences. Using our calculator, this number divided by 2 times 63 pi plus 49 pi gives us 15,179 millimeters squared. Now, given that it is area, we usually will square the unit. This is our lateral area. This is our volume. Now, all we need to find is the total surface area. Given that this is a cup, this top part will not be included in our total surface area. So we already have the lateral area. All we have to do is find the area of the base, which we already have. We called it A2, and add it to the number that we just found. So I'm going to add 1,885.74 to this. 1,885.74 millimeters squared. Adding these two up, and I'll highlight this part just to suggest that this is the lateral area, plus 1,885.74 gives us a total area of 17,065. 17,065.68 millimeters squared. And there you have it. That is how to find the lateral area, total surface area, and volume of a frustum.